We have data, drop frames 0, CPU 43%, 60 FPS. I wonder if the Intel Arc is going to ruin this. Would not surprise me. It's been stable though. I have not had a single issue with it so far. Intel Arc. I would not be surprised if I did not have a single issue with it. Because I'm not spending $700 something on a video card. Sorry. Share this. Alright, we're gonna get started. So, first off, I don't know how this audio is gonna be. So, here's the deal. About a month ago, I decided it was a good idea to move my office around. Now, I moved my office around and I left the audio equipment over on the other side of the office, and I have not moved it to this side of the office that has my streaming set up. Now, normally I would get everything set up on this side of the office, but I don't want to, because my lease here is up January, February-ish, and I'm getting the hell out of Palmdale. So, the audio equipment is not going to get moved over here, so any streams between now and when I move is going to be on the webcam's built-in microphone. I'm sorry if it's bad, but I don't care. It's a live stream, and whatever. It doesn't matter at this point. So, anyway, we have a randomly dead M2 MacBook Pro that came in for data recovery. Now, this is the first M2 that I've laid my hands on. It's mostly the same. Let's see here. Do we have a board number on here? Is it the same 820? No, it is an 820-02773 something. So this is the first M2 that we're going to be taking a look at. So I'm going to go ahead and get this board out real fast. Most of it's already done. So I'm just going to pull this out. And we're going to see what's wrong with this. So it's mostly the same as the 820-2020. It's put together the same. It looks, even the model number is the same as the previous machine, A2338. So there's probably not a lot of differences on this board other than firmware and the processor. But it will be interesting to see what caused this board to randomly die out of nowhere, so they say. And we're going to find out. So I just took out the last screw. I'm going to get this board out. We're going to have a look. So it is pristine. Alright, no, this board is different. The 3V7, alright, this has a few differences actually. Alright, well, let's get into this. So, Caleb, can you find another M1 board here? Possibly the previous year? Okay, thank you. Alright, so here we have an M1 board, then we have the M2 board. Let me hope this microscope is going to work. Properties, come on. Video. There we go. That should be good. It looks a bit off, does it? That's fine. Whatever. Okay, so let's take a look at the M1 board side to side. One thing you'll notice, I'm going to just hold them both up to the camera. The M1 board is much more populated. Here's the M1 board. Let's get a look at that, right? That's the M1 board. here is the M2 board. Notice there's quite a few things missing on it compared to its predecessor. So a lot of differences here. So we're going to take a look at this. Simple is good. So I like the fact that I see less things. A simple board is better. So let's go to the microscope. Let's just give it a visual. First things first, a visual inspection under the microscope. Before we get into anything else, we want to do a visual. So really common that on M1s or M2s now, this area, the Wi-Fi area, will get corroded. And let me get this dialed in. It's been a long time since I've used my microscope camera. So this area will get corroded and these caps will short even though they're underfilled. Not happening here. Looks clean. CD3217 area looks clean. Little bit of liquid there, little bit of liquid there. Overall, that looks very insignificant to me. Could that be a problem? I don't know. Possibly, but that looks very insignificant. We have an ISL 9240. Good to see that has not changed. And we have two ROMs here. I'm guessing these are for the CD. No, I don't know, because there's our TBT ROM. Winbon, those are ROM chips. That's interesting. I don't know what those are for. Anyway, carrying on. On the M1s, it would be common to get a shorted cap around here. It's not the case. Everything looks beautiful. Backlight area looks good. Everything looks good. Now, one thing I see missing is our 3V8 VDD main circuit. Now, I'm guessing it's going to lurk under this shield here. Let's see. Or it's going to be outputted by a PMIC now, which is worse, but let's see. Alright, there we have a PMIC. Ah, okay, there it is. Same chip, but it is now right here. Which I like because it's protected under the shield from liquid. Somewhat. I shouldn't say fully. Anyway, so we know we have a little bit of corrosion. We have very insignificant corrosion, at least in my professional opinion. So let's go ahead and plug this in and see what it's doing. So M1 Diagnostics, M1, M2. Not the M1 Pro. The M1 Pro, M1 Max, total mess of machines. I do not like working on them. They often will have other issues in the enclosure. Actually, I have something really cool to show you guys. Okay, so this is now reaching 20 volts outside of the enclosure at 0.6, 0.8. So that's interesting. So basically, it appears this machine is booting based on the amp draw. Yeah, it looks like it is booting. Or is it? Yeah, the CPU has some heat to it. Okay, so this was a little bit different. I did plug in the USB-C amp meter originally in the USB port, and it had 5 volts and a weird cycling type voltage, which makes me think another common thing on M1s and really all USB-C machines is simply a bad USB-C port. So let's go ahead and pull this off. Oftentimes the USB-C port is not even bad, it just needs a little corrosion, a little TLC. And that would correlate with that little bit of insignificant corrosion that we saw by our CD3217s. And let's see. Overall, I don't think so. It looks pretty good. No, look at that. We have corrosion right there. That's definite corrosion. Not terrible. I've seen way worse. But let's go ahead and see if it gives us 5 volts on this port. And if it does give us 5 volts on this port, then we have a diagnosis. And yes, my nails are disgusting. I apologize. I need to trim them. Well, pay attention to my nails right now. And my hands are incredibly dry as well. Come on. Done it with 4 strings. It's embarrassing. Anyway. Interesting. Okay, so now my plan is I'm going to put this back in the enclosure, connect everything, and see if we get 20 volts. So that's the next step right here, is put this back in the enclosure. And see what happens. So, first things first, I'm going to go clean this USB-C port just a little bit. Put it back. And very oftentimes you will see, I think I might have just found our problem by looking at this. We'll get into it in a second. Where did I set those? Here they are. So we're going to put these screws back in. I don't want to spoil it, so I'm just going to look under the scope myself. Yeah, maybe. Just going to plug in everything but the battery. See what happens. We're seeing so many pink bars. Fluxgate suddenly. Okay, that's not Fluxgate. That is going to be from the data cable. I really dislike when people call that Fluxgate, because what happens is we'll get repair shops that'll call us, that'll say like, hey, we have Fluxgate, how much is that to fix? Well, it's $259. But then they send it in and it's actually not Fluxgate. It is a LCD data cable issue. Now, I see some people will find a little indentation on that cable and they'll run a little wire across it. Personally, I don't like that. I don't think that's a reliable repair. I don't think that'll last long. just because the fact that you're soldering a wire on top of a flexible cable like that, it's not going to work. Now that's different with the flex gate repair that has an overlapping cable where the wires run that's very strong. The data cable isn't. Alright, so this is turning on. I don't know why, but it is turning on now. So my guess is this has an intermittent issue. Because this is the second M1 this is the first M1 that I looked at tonight was, alright, no, we have a problem. Our fan just went to max and we lost image. So we had an Apple logo. Okay, yuck. The version of macOS on the selected disk needs to be reinstalled. Use recovery to reinstall macOS or select another startup disk. So in this case, lovely. When this particular thing happens on an M1, you're basically screwed. Here's what we have to do. So what we have to do is, one, this probably happened because that little drop of liquid on the board corrupted some firmware nonsense, and therefore the processor could not boot the thing. You guys know what I'm talking about. The OS. Sorry, it's late at night. So what we're going to do, we're going to take care of that liquid. Now we have to find, the hard part is we're going to have to find the force DFU pins. The M1s are always a pain to do it via the keyboard. These are probably going to be just the same. So I'm going to hope that they didn't change it, but they did. Lovely. So let's try and do a little reverse engineering here. Yeah, this is really not fun. So what we have to do is do a DFU revive. Now a DFU revive on M1s is a bit different than prior models. On M1s it actually reinstalls the OS as well. That's why it takes a really long time. Now, if you don't have enough free space on your SSD when you do a DFU restore, or if the machine gets into a state we need a DFU restore, you're out of luck. You cannot restore it, you cannot erase it, you cannot revive it. It is a paperweight. And yeah, so I don't know if they fixed that, but that was the case before. Anyway, we have to take a look at hang on here. Figure out why this is doing this. I think COVID came from this microscope. You see that little virus thing that pops up when it starts? Interesting. Anyway, so let's try and find our force DFU. Now, these look like transistors, so I don't want to mess with any of these. Yeah, I don't think there is buttons for this here anymore. That there might be. Yeah, that's what kind of sucks about this. Anyway, so this little thing, we don't have any board view. We don't have anything. We're going to take care of this. Now, I am no longer going to be using Amtech or Inventec Flux. So, here's the story. Basically, LAX lifters, I have almost 7 years of experience now. So, a company came out and said that they're the genuine Amtech, they've split ways with Inventec, whatever, all kinds of drama. Inventec is saying that's not true. Inventec has sent us threatening letters saying we're a distributor. We're not a distributor of anyone's products except our own thermal paste. But anyway, I'm not supporting either Amtech Direct or Inventec anymore, so I am using my own Flux, which we will be selling in several different variants. So this first variant here is the liquid BGA Flux. That's the only formulation right now that is decent right now. We're still working on the rest of them. So I'm just going to use that for right now. This is a no clean liquid flux. It works pretty darn well for what it is. It's unlike most other liquid fluxes, and you'll see why. So from now on, we're just going to be using our own as much as we can, honestly, until they're all released. So it is a liquid flux, but as you can see, it really stays put and works pretty darn good. So yeah, I'm not supporting Amtech or Inventec anymore. Both of them done, and we are coming out with our own products. So I'm gonna actually lift this little guy. I don't know what it does, so I'm gonna lift it and make sure that that's okay. That's good. Yep. And just so I can get some pricing expectations. So Briz, not yet, very soon. So this is a liquid flux. Liquid fluxes are typically used for like BGA, CPUs and stuff, but this works pretty well for other stuff as well. It's probably not the best for soldering iron stuff, but for hot air, it's awesome. Right now, we're probably gonna be doing 10cc, 30cc, and then a 3cc. The plan for the 3cc is probably like a sample type, you know, a syringe like this side, and we're probably going to be selling it for like $1.50 for one of these tubes for this one. Also in development is a no clean tacky flux and a specialized cleaning flux. Now this specialized cleaning flux will have to be removed, and we're going to have some disclaimer on it. Basically, it will clean corrosion very, very, very well, unlike anything else. So we're working on that one. That one's coming along really well. Our no clean rosin-based flux, we're still working on. We've tried several different things. We've tried several different formulas. It works, but it's okay. I'm not going to release something that's just okay. Just like with thermal paste, I'm not going to release something that's okay. This is good, and this will be released very soon. Briz, very soon. Okay, so with that being taken care of, we're going to go ahead and put it. And another thing about this is it cleans very, very well. So, you know, with the tacky fluxes, they can be kind of a pain to clean. This is just a breeze to clean. I mean, look at this. When we get enough acetone or alcohol in our Q-tip, it is anyway. It cleans very easy. The residue is totally harmless. You don't have to clean. They likely use glycerin in the formula. Glycerin is hydrophilic. This doesn't have glycerin in it. Yeah, it cleans up really nicely, and it works pretty well. Okay. So Caleb here is going to put this back in the enclosure with everything connected, including the battery, but nothing else. No screws, just the battery screw. And then, do you have anything else you need to take a look at?
I got a 1398.
That's boring. It's CPU MOSFETs. No, not that one. That one sucks. Flux isn't something that's necessarily really hard to make, but yeah, it's thermal paste is much harder than flux, I will say that. Okay, I bet I could find something that you're just doing this.
You know better than I do.
Alright, if I found something, which I just did. Come on now. Alright, this one will be interesting. So, yeah. Generally, when I open a laptop and I see this, it generally Yeah, if I see blue tape on a laptop pulling stuff in, no. This is components in here. Oh no, when there's chips in blue tape, that's even worse. Or screws, or there's something in this. I don't know what it is, but it's not good. Anyway, E2141, severe liquid damage. Worked on prior. Oh boy. Good news is, there's nothing by our SSD areas. So this might be savable. This might be savable. Go ahead and that is not getting sent back with screws. Sorry, I'm not gonna dig through that tape. Here we go. Okay, so we have corrosion here. We have a lot of corrosion here, 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 near our CPU. We have corrosion here, near our backlight, and pretty much that's it. So, first things first, do we have a short on PP bus? Oh, and a lot right here too. This looks terrible. So, first things first, we're going to clean this up. So, first I just want to put some flux down and get this clean. So, a little bit of our flux. A liquid flux is probably not the best for this type of application, but I don't want to get Mantech for satisfaction anymore. So, actually, what I can use. No, I don't want to show it yet. Or do I? I don't know where it's at, so I guess not. Here it is. Okay. This is our specialized cleaning one. It's a Tacuflux. You know? It smells oddly of citrus. I wonder why that might be. But this one is specifically designed for corrosion cleaning. We'll use that. Yeah, the first flux, Tony, is a liquid flux. Liquid is going to be low viscosity. Okay, so somebody else was here. Obviously, they ripped off some capacitors. Some more right here. So this stuff actually kind of chemically breaks down the corrosion a bit, makes it easier for the ultrasonic to. Citrus equals acidic, absolutely right, which is why it would need to be cleaned after each use. But all fluxes have some form of citrus, acids in them, some more than others. This would be a medium activity. Notice how it kind of starts bubbling as it degrades the corrosion. It's the formula at work. Alright, so now I'm going to let the board cool. We're going to get a baseline voltage. See what's going on. Alright, and then while that's cooling, we're going to see what this M2 is doing now that it's in the enclosure. Alright. When do we get to have the having a visit from you in PLD land? We haven't seen you in years. I've never been to Australia in my life, and I don't know when that might be when I would go to Australia. So, yeah. Good question. I don't know. Alright. So, we have our M2 here. Interestingly enough, now it is doing nothing. So now we have no action on the USB amp meter at all, nothing. That almost makes me think that the Apple USB-C charger died again. So I'm just going to unplug it for a minute and see where it goes. So yeah, so when we do move to our new location, we probably will be doing classes as well for MacBook repair. It'll probably be a 3-student class, and it'll probably be more of an advanced class, but that's definitely in the books of the plan. But yeah, it's definitely time to move on from this current store. I've been here long enough, and it's not getting any better with the local area. There we go. So it worked for a second, then it died again. The charger, that is. Oh, there it goes. Alright, and now it boots just fine. So what we did is resoldered that one chip that was corroded, and that was preventing this machine from booting into the operating system. So this is good to go. This is done. Hopefully you guys can't see the name here. I don't think you can. But that is good to go. Caleb here is going to put this board in the ultrasonic cleaner for 2 minutes on the backside only. And then that is done. Okay. Where are you going to be moving to? It's kind of a surprise.
Or maybe New York.
Not New York. No. I'm not moving to New York City. Not happening. Not moving to New York City. Not moving to Texas. There it is. Can I have a sprayer of alcohol around here? So as far as timing goes, I'd like to be open by March 1st, and I would like to never come back to this store by March 1st, and hopefully it will be before then. We'll see what happens. So, who would actually, does anyone want to see content on that as far as choosing a new store? I know Lewis, and when Lewis did it, it was really popular, but I feel like if I did it, it would not be a hit at all. But if you guys want to see content, then we will. Alright, so this charger is not behaving properly. It is not working again. I'm going to unplug it again and see what it does. So if this happens to you, unplug your charger for a few seconds and plug back in. Then it'll work again for a short amount of time unless it dies again. So I don't like the fact that a lot of Apple machines sometimes don't boot off of aftermarket chargers, so, you know. 2 components were blown away, 2 components are missing from the motherboard. I'm well aware of that. It is a tantalum capacitor that is not important. It is a, the other one was some ceramic capacitors. None of those matter for turning on. I noticed them, I don't care about them. So, the way that the machine is assembled and everything, it's least of my concerns right now. If it was something critical, I would have noticed it and I would have done something about it. But if it's a capacitor like that, I definitely noticed it. I could show you guys right where it was when it flew off. It was this one right here. Right here, a corroded tantalum capacitor that probably was shorted to ground and will cause more issues. A backlight ceramic capacitor and a row of capacitors likely for some sensor circuit right there. None of that will stop the board from turning on, and I don't care about that right now. I want to get the board turning on before we do anything else. So, as of right now, all of the USB ports are totally dead and nothing works. Now, I don't know. Let's try it on another board. We got to rule out if it's our charger or the board. I don't think the potential landlord's going to let me fly a drone indoors. So I don't think that's going to be the case. Alright, so works on this board. So it is just, this board is dead. Now why would a board to have 0 volts or anything like that? Typically either an open circuit or a short circuit. Now I don't see anything major in our USB circuit, or do I? I wonder if anyone sees it. Does anyone see it here? It's just me. Bingo. So these guys are, I don't have a second monitor set up, so I don't want to share my screen right now, but these are our VB3 and UPC capacitors here. Let's check for a short to ground. So we are going to get our meter in tone mode, continuity mode, not diode mode. Then you guys can't tell. So alright, 400 ohms. So I'm going to go ahead and pull these guys off. Just because I want to roll them out. We don't want to replace CD3215s on this board. These are non-critical for right now. We want to rule out if they're causing an active short. Meaning a short that's only present when the board is on. So there's that. Anyone else? Let's check for a short on PP bus. So I'm very concerned for the well-being of the CPU here. And we have 0.98 ohms to ground. That is not good. So what I want to go ahead and do is see what we're reading on our coils near our CPU here. If we have 0.98 ohms, then we very likely have another, or we have a dead CPU or shorted MOSFET. We have 3 ohms here. We have 3 ohms here. We have 5 ohms here. And we have here for our GPU 4 ohms. So we do not have a shorted CPU MOSFET from what I can tell at this moment. So what we're going to do is we're going to inject voltage. I would probably say this guy right here is suspect, maybe. Anything else over here? Nope. Okay. Yeah, so the CD3217s don't really die that often with liquid, and they're having a lot of compatibility boards on the 1700 and the 2150 or the 2251. So what we're finding out is you can replace them with known good off different boards, or even the same board sometimes, and they end up not working. So we're not going to replace that CD unless we have to. We're going to reuse it. With that amount of liquid by it, I would have no concerns over that. Alright. So we have our wire here. We have our power supply set to 1 volt. And we are going to grab our thermal camera, which is right here. And we are going to do some thermal imaging to find out what is shorted to ground on this board. So I need the USB-C cable. Where did that go? Here it is. What is the deal with Intel Arc Control Center handling device connection? Does anyone know what the deal is with that? I don't understand it. Alright, I'm going to have to share my screen. Display capture. Alright, so hopefully you guys can see that. We're going to get this dialed in. And I'm going to connect my ground lead. Pulling about an amp. Anything by our CPU? Nope. Nothing. A little bit right there. Flux on the end. Ah, I wonder what that is. Right there. So where are you? What are you? This looks like something maybe on the other side. Right in this area. Something right here. So I want to turn this up a bit now that I have it localized. And it appears it is on the other side, right over here. And we're going to zoom in, and we're going to... What even is that? Oh, that looks like it's almost an internal short. Hey, can you take a look at that 27-inch iMac, by the way? So we have a resistor right there. And yeah, let's take a look at this. Over here. Something weird is going on. It's an internal short. Of course it's an internal short. It's always an internal short on this channel. I never get a lucky, easy PP bus short. It's always an internal short. Oh well. Let's go ahead and take care of that. So something got very hot there. It caused that resistor to totally look at that. Isn't that weird? Just so welded to the board. Alright, we're gonna have to start cutting. So I'm just gonna cut that off first. We're just going to go layer by layer until we are through. Let me get sharper. This one would be okay. And that looks pretty deep. I go wide in the margins to give myself space. This looks like it is almost through the board. Luckily it's kind of near the edge, but this is deep. I need the drill. Alright, I need to find my Dremel.
Just let it dry.
And I need a bit. Hopefully I'm not out of bits for the Dremel. I can't do this without a nice fine short bit. Usually, I will say this, when an internal short gets to the point where I need a Dremel, your chances of that board being saved go down to very, very low numbers, but I still have to do it. I still have to do everything I possibly can. Most people will just throw them in the trash at this point, but I don't really like that. If there's even a slight chance of me spending a few hours on something to try and save data, I'll do it. As long as I find my drill bits. Make sure to wear safety glasses when using power tools. The problem with wearing safety glasses with power tools is you can't see anything through the microscope. So I don't do that. My drill bit pack. Huh.
Some of the iMac.
What'd you say, Caleb?
What's wrong with the iMac?
Apparently it keeps restarting to the lock screen. Or going into lock screen by itself. Something along those lines, I don't know. Once I find these drill bits, we can get started. We're going to use the tip of one. Should be good enough for now. Okay. Some fluid in here. Now we gotta clean up. So we got the short out, well the black layers out, and now we have to, we have to remove this capacitor, because that's never going back on in this area. And then we have to go through those layers, and that was deep, that was really deep, I mean. Now we just have to cut. Pray that this will resolve the short and that we didn't cut through anything critical. This is just for data recovery, by the way. So let's start over here. I'm just going to go. Oh, it goes even further over here. Wow. Okay. Yeah, this, well, we could see through the board right here. Hang on, guys. I really need to find the drill bits so I can continue this. I have a feeling I kind of fell somewhere, maybe. That likes to fall. But yeah, this unit's not looking good. Lot of board needs to be taken out for this to even have a chance of working again. The more board we take out, the less chance it'll work. Hold on, guys. So, always one of those things that when you're looking for something, it'll always be in front of your face. And then when you are not looking for something, if you're not looking for something, it'll be in front of your face when you're. I don't know. Whatever. It's like I'm just trying to find my drill bits. Anyway, they were here before, and I did not need them, and now I need them, and they're not here anymore. End of story. Simple as I could put it. Caleb, have you seen them around here? They're a little plastic container that has like 4 or 5 different colored drill bits.
I know what you're talking about. I have not seen them.
I feel like they fell into the donor board pile. That seems like where they would be lurking. Because they're where they're supposed to be is empty. But there's donor boards right under them. And I got them. So I'm gonna go with the small one, and we are just gonna. We have to go until we don't see any of that black nonsense layer anymore. That's all carbonized burned PCB. It's all gonna go. So what we're gonna do, we need a nice surface to do this on. Not a surface. I don't know what I'm saying. I'm tired. I'm exhausted, actually. But we need to put a liquid in here. This is isopropyl alcohol, just to kind of clear the copper out. And here we go. More alcohol. And we're going layer by layer. If you guys have ever seen what a landfill kind of looks like, it's like layer by layer like that, or an old landfill. That's what we're doing. We want a nice clean surface where you can see all the way, totally unavoidable, which is not a good thing. So our hope is that we can get this into DFU. If we get this into DFU, we can get the data. And that's it. Well, I shouldn't say that. I said if we can get it into DFU and get it to read the NANDs, we can get the data. So. I'm gonna spray this off and clean all these upper shards off real fast. And so there's still a little bit that I see. That's it. I think the short is gone. Again, I'm going to flesh it out a little bit more. And we're going to go back to the other side, because the other side is going to need a little attention too. And then we could work on getting the layers all separated and maybe run power through this and see what it does. I kind of want to see where those two traces go now. There's a lot of traces that ran through here. And actually there's more short. We did not get all of it yet. Wow, it's still... No, CPU does not need to be swapped. If this fails, then there's no way to get the data off of this. Swapping the CPU is not going to do anything. You theoretically could swap the T2 and the NANDs and everything, but yeah, I'm not doing that. This extends really, really far. Again, I'm going to flush it again. It is right near the edge. What I'm hoping is if it can get in, if I can get it, if I can get it in the DFU, I can get data usually. Just so extensive. This is why you should have a fuse that does its job. This should never happen if the fuse was rated properly. But it's not, so this is what happens. It's a lot of work, School Kids Production. I would not send you my expensive MacBook. Well, guess what, buddy? The thousands of other people that send us their expensive MacBooks trust us to do this, and believe it or not, we have gotten data doing this many times. So you don't have to send your expensive MacBook. You can go send it to someone else that'll fail at getting your data, then send it to me. And we'll have to charge you more because someone else will probably ruin your board. So, what can I say? Back to this. There's no other option when you have an internal short. You have to do this. If you have an internal short, this is what you have to do. There's no other way of getting around it. Yes, it's ugly, but you know what? It works. If you want to see a full video of it actually being done successfully, here, we'll link that. Let's see, let's find it here. Don't get me wrong, when it's at this point, the chances are low. But it can be done, and watch it. I think you overdid it, bro. Well, guess what? But you're not under the microscope. Unless you're under the microscope looking at this, then you cannot tell me that it's overdone. Maybe I'll send it to Paul. Go ahead and do that. I talk to Paul regularly. Where is my other blade? We have to separate all these layers. There's no other option around this. So unless you have done this, unless you are an experienced repair technician that has done this, so unless you are Lewis, Paul Daniels, Paul S., anyone like that, then you don't tell me how to do my job, please. Well, this is what happens. These are the cases that I get, these are the cases that I handle, and these are the cases that I make money on and keep my doors open with. And watch this all be cleared and we will get into DFU. The more experience can only be tolerated so much. I totally agree with that. So a swap also introduces the fact that you can damage the NANDs themselves. Heat is a big thing with NANDs. These boards are very thick and the NANDs do take a lot of heat to get off, so I wouldn't necessarily want to just swap a NAND for no reason and possibly ruin the data forever. So that's why we often will go for this method first, because this is not going to harm the NANDs. We just want to get this good enough where it, and guys, don't tell people to be quiet. People have every right to comment. See, I don't need people to defend me or anything like that. You guys can comment and say whatever you want. I don't care. I'll counter it if I feel like I need a counter, but otherwise, just let it be. So, what's going on with that iMac?
It is fine.
She's brought it back like several times after the SSD and it says it keeps going into the login screen. I told her it could be her keyboard if she's hitting lock on her keyboard. She doesn't say it restarts, says it goes to the login screen.
Well, I turned off ask for password. So if it goes to sleep, it should not ask for password on wake.
You think that's all it is?
That's what I'm doing.
Yeah, that's another thing. This is like a $600 board. So you would have to buy a good board for $600. Then you're going to have to deal with whatever firmware stuff comes up. The T2 is also very heat sensitive. The T2 you can kill with heat very easily. So you add another variable damaging the T2 with heat.
I got a Flux gate here.
You do?
Mm-hmm.
From who?
A lovely customer. We love our customers.
Almost done cleaning this up. This is like removing cancer from a board. Basically, that's what this is. This is like cancer. We have to make sure our margins are clean. There's no cancer left over. There's quite a few traces right here. But again, critical function is what I need. And I can run wires to these if needed. What I could do is I could see where they go. So I could go down a couple layers, but that's what we'll do last resort. You can usually see where traces run. It's like maybe a few more here. No, and there. Okay, this is looking pretty clean. So right now, maybe a little more. Trim right here. We don't want any traces crossed whatsoever, any layers crossed. It's like more short right here. I'm going to try and leave that be. I don't want to take any more from this, I really don't. Flush again. This board will never turn on and work properly again. What it will probably do is enter DFU mode so that the NANDs can be accessed. That's what it'll do, and that's what we want. We don't need it to do anything other than the T2 to boot, load Bridge OS, and read the NANDs. That's all we need it to do. So if we can get our main power rails back, if we could power the T2, if we could power the NANDs, we are probably good to go. Alright, so I'm pretty happy with this. I want to do a little bit more right here. Just make sure that these layers are clean. Don't want to go too far into the TPS area, but I think we're good. Rob Brown is here. Finally, someone that knows how to fix boards that's not going to tell me how to do my job. So Rob, this had a internal short all through the layers, and people were saying, oh, I wouldn't send my expensive device to you seeing doing this. Well, what is the other option? And Rob, you're an electronics engineer, aren't you? So Rob's an electronics engineer. He'll tell you the truth. Rob doesn't have just a YouTube degree like me. He went to college. It's concerning being this close. I wonder what Jessa would say if she was with you during this repair. Actually, I did this at her shop on a GPU. And I told her the damage is too extensive and she wanted me to continue, and I said no. That one was bad. And I think, watch the interview I did with Jessa, and we talked about an internal short like this before, so yeah, you can see it there. Alright, so this looks nice and clean. The short is gone. Now we're going to dry it off a little bit. Actually, you know what? This thing's ultrasonic. Caleb. Ultra. Just 2 minutes aside. That's all you need. Okay. So that is done. What we're gonna do is we're gonna wait. We're gonna ultrasonic it and see where it goes from there.
Flux gate.
Yeah, let's do a flex gate.
We're going to take the shield out.
Why'd you take the screen out? Don't take the screen out for flex gate. You have a paper towel? Sounds bad.
Things have changed.
Alright, and
I'm carrying this one.
there's some flex cables over there. If you can grab me one. That has 2 cables in it.
Where?
Over there, on the top of the thing. Thank you. No, I said one that has 2. That's just the camera.
Oh.
Actually, you know what? No, they're not over there. They're in that box right there. Those, yeah, sorry. They're in the box over there. They should have a rubber band on them.
What box?
The only box that's on your desk.
Oh.
Alright, FlexGate as usual. Are you sure? What took, actually? 637. Thank you.
Ow!
Wait. I'm confused here.
You are confused.
Like, okay, how did it take me that long to type that in? Got it. Okay.
I verified it.
So we have a typical Flux gate that we're going to take a look at here and repair it. So, hang on one second. Shut this off so I can hear notifications on my phone. It is not time to go to sleep yet, therefore I don't want my phone in sleep mode. Anyway, so Flux gate, very typical presentation. And this is doing this thing again. So we have a very typical Flux gate. We're going to take the shield off, and we are going to tape it, and then we're going to cut. Where's my T4? Oh, here, right in front of my face. Of course it's right in front of my face. We should give this guy a new bezel, too. I used to be scared of replacing the bezel. I'm not scared of replacing the bezel anymore. It's just a nice touch. Like, you know, getting your machine back, a lot of people really dislike this cracked bezel. Caleb, have you removed a bezel?
No.
You want to remove a bezel?
No.
Why?
I'm gonna go home soon.
Why are you going home? It's only 10:34 at night. Who
Good question.
who wouldn't be working at
Never mind.
10:34 at night?
I'm sorry to ask.
What is going on there? Yeah, everyone works at 10:34 at night. I've never seen this. There's a snowflake on this display. This camera is not gonna last long. There. Okay. So first things first, we're gonna take this. Yeah, anyone who's not working at this time of night, yeah, that's just laziness. Yep, me too. Rob, I've had people that have specifically said I want that bezel replaced. And I've tried to do it when I didn't know how to do it, and I've ruined displays like that, but I know how to do it. So. Okay, so first things first is... Alright, now we're ready. So we are going to cut right here. Just like that. Not going to worry about that little light scratch there. You're not going to be able to see that. And we're going to scrape off the coating here. I want to show the chat that that board goes into DFU after. I really want that to go into DFU. Okay, so that's done. Ready. Let's get that tinned actually. Oh, I need a tacking flux for this, so. Sorry, I don't want to do this. I don't want to use this. I'd rather use mine, but I need the M2. I'm just going to get this tinned, and the iron's going to take the rest of that coating off. There's that. So we want to make sure there's two nice big solder blobs there. We're going to get our cable. Now what we're not going to do, I see a misconception. People think you just run the wires across it. You don't. There's a trick to it. You want to overlap the cable so it's strong. If you just connect it together with wires, it's going to fail. So we're going to do it. I'm going to show you how to do it the proper way. So first off, we're going to get our cable. We want to cut the cable the proper length. So what I do is just, here we go again with this on camera. We're going to lay out our new cable and our old one side by side like that, okay? And we're going to cut it about, we're going to go about like so, right? So I'm going to put a line in it so I can cut it. Want it to be like 3/4 of a centimeter longer or so. And that's fine. So now what we have to do, let's set this display aside. Just to be a little cleaner of a cut. There we go. I don't like that cut at all. I like it to be nice, clean, not jagged. That's what I want. Okay, now these cables are a little bit weird. So what I like to do is just get a little bit, get it kind of scratched up. And once you get it scratched up, see this one's doing good, so I might not have to use acetone. On some of them you'll have to use acetone, but this one's coming off really nice. I'm letting the blade do all the work. I'm not pushing on this. If you push on it, you'll ruin it. Caleb, can you do me a favor? There is, go find a A1707 or 1990 in the pile of broken screens that has an intact bezel, and then the heat mat over there. There's a heat mat on that bench over there. Just plug it in and put the screen on and clear anything that's potentially going to cause a fire over there. Alright, so our cable is prepared. We're going to flux. Nice big blobs there, good. Set this right here. I want to clean up the debris on my workspace. Um, 70. 70. Set it to 70. Okay. So we're going to lay these cables on top of each other like this. We want them to overlap. A lot of people will like line them up and run wires. You don't do that. You overlap them. So you want a good few millimeters or millimeter or so of overlap. And once it's connected, you'll never get it like how you want it. You just want to get it tacked down on one side, then do the other side. You have a nice strong joint on that side now. Now we can push it down like so. More flux here. Now I used to put wires over here. I no longer do that. I do not feel it is necessary to put a wire on the ground pins. And here is a hair from a pug. Do not want a hair from a pug. Here's another hair from a pug. Don't hold your pug before going to work. So now, it's a really nice strong joint here. This flux is terrible. That's an NC559V2 from 2020. This is 560 from 2019. 560 is better, much better. I don't care if I'm spending a long time. I want to make sure that these solder joints are strong and perfect. Like that. Beautiful. Okay, that cable will not run out of V3. So there's a scandal. I'm not going to get into it. I'm not using V3 anymore. I'm not using any Amtech or Inventec products unless I absolutely have to. We're developing our own products and moving on from there. There's a bunch of drama between both companies. One company is saying I'm a distributor, the other, and I'm not. I've never distributed any. I'm not dealing with it anymore. I'm not using any. I'm probably going to switch to MG. I'm probably going to get a few tubes of MG chemicals Flux in the meantime and throw all the Amtech I have away, just because I'm not supporting either company, Inventec or Amtech Direct anymore. Both of them I just test now because I don't know who to believe. I don't know who's lying. I don't know who's telling the truth. And yeah, I'm not getting into it. And I'm not going to put up with being told that I'm a distributor of another company's products when I'm not. I don't distribute any. So, you know, I'm not. Yeah. And furthermore, yeah, just never. That really ticked me off when I got a certified letter from Inventec. It's not the fact of the contents of the letter; it's that they're claiming that I'm a distributor, and I'm not. I've never sold Flux. I did briefly sell Flux in 2019, and that was Inventec's Flux. That was literally. I could even pull up the order from the email order from Inventec Performance Chemicals in Deep River, Connecticut. That is the only time I've distributed Flux. I've never distributed Flux from AmtechDirect.com. The shelf life really doesn't matter on Flux. It really does not matter. Still some 2017 that's just fine. Yeah, I don't really care what Northridge Fix does. I believe he sells the Inventec product. Which Inventec claims Amtech Direct stole their trademarks, and I do believe it. Like, I do believe that Amtech Direct is using the Amtech trademark improperly or whatever. I don't know enough about the situation. I don't know who to believe in it. I really don't know. Inventec, I want to believe Inventec, and I do feel bad for Inventec if they're telling the truth, but I don't know who to believe. So, I'm simply a third party. I'm not promoting either company. I don't condone nor condemn either company. I'm out of it. I'm not, you know. Nope, not going there. Not dealing with it. Took a little bit off, but we're gonna make this work. solder on there. Better. This is something that our tacky Flux will not do, is turn black like this. It's terrible. Thank you, Briz. I really appreciate that 20 bucks. That's the most someone's donated on this channel, I think, is 20 bucks. Thank you so much. We're done here. Yeah, the thing is, Mo, is Apple will not cover this. They don't cover it anymore. No matter how hard you try, they're not going to help you. So, you either pay $259 for me to fix it, or you pay $500 for a display replacement, or you have a broken MacBook. Those are the choices. Go. I'll clean this up a little bit. Backwards. I dropped a Q-tip in the acetone. Is that 2141 baking, Caleb?
It's done. Didn't get clean all the way though.
What?
Didn't get all the way clean.
Let me see.
Hot.
No, you're right. It wasn't in there long enough. The main thing I wanted was the copper to be gone, so that's fine. Yeah, we need to. All I need to do on that is run a wire and throw it in the DFU, which I will show right after this. So. Look at this. Burnt flux residue. I use Gootwick, something or other. Or MG Chemicals Superwick, one of the two. Whatever I can get. MG Chemicals is good, and so is Gootwick. Both are decent. This is clean enough now that I can properly take care of this and do our little bridges that we always do on these. So I'm going to clean this all up, get a little bit more flux. We're going to get our iron, we're going to turn our temp down. Bridge. 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 That's good. I want this to be bridged. I want this to be strong like this, and I want all these LED return lines to be connected to each other. Get a solid flux game. I have not noticed that Gutenberg phrase at all. So, yeah, I don't know. MG does a little bit, in my opinion, but I have not noticed Gutenberg fraying in any significant amount. So this is done. Take our tape off, clean all the flux up, put some acrylic on it, and then change this bezel off camera. All this flux needs to be cleaned up really well before we put the acrylic on it. I no longer use the UV coating green stuff. I use a clear acrylic conformal coating for everything when I conformal coat. So that's what we'll be using, and we've had very good luck with it. Okay. So we're gonna just get our tweezers or something. Put it in here. You only need a single layer. Just like that. This is really good stuff. It's really strong. It's really rubbery. It stays in place. I like it very much. There we go. We're done. It's going to harden. It's going to take care of itself. Try and keep the cable down a little bit just for a second while it cures. Starts to tackify anyway. And that now will stay in place and be a really solid repair for a long time to come. We'll never do the FlexGate thing again. It will be perfect for a very long time. Just going to kind of hold it while the acrylic dries a little bit. Give it a little hot air to kind of help it along. Yeah, you do not need UV for this. It's air cure. It'll cure very quickly through air. If I put a little hot air on it, it'll cure even quicker, and it is a very strong material when it is done. It's MG Chemicals something. MG Chemicals 419D. It is infinitely better in my opinion than that UV. No, I think one line isn't good. Every line is good here. Every important line is perfect. Everything looks good. The only thing that's not is the backlight. Everything else looks soldered and good. Everything else is soldered perfectly. The third one right here that you see, that's the ground, another ground that never gets connected. We never connect those. So yeah, this should be good. The coating is not going to run. We're going to change that bezel in a minute. And now I want to show you guys you know, let's just plug that in just so everyone sees that it works. First off, here's our board that needs to go in DFU. So let's first check and see if our short is still on PP bus. So let's see here. I would expect high resistance to ground on PP bus. And I still have a 0.4 ohm short to ground. So we still have a short to ground, unfortunately. So that means something somewhere is still shorted. And it's probably somewhere in one of these layers that's touching. Like right there. So yeah, this is the thing with internal shorts. You often have to go back and forth. Make it perfect. And you'll get layers that kind of touch each other. It will cause issues like that. Don't want any overlapping layers. So now, let's see again. .72 ohms, we went up a little bit. Where is it? I would not recommend injecting like this. Just because we don't know where it is. We could. It would be a last resort. I want to kind of just... Oftentimes, I've done this many, many times, just so you guys all know. But oftentimes it's just going to be a little burr that's causing it. Right around here. Let's check again. Of course, the other option is we have another shorted component and we're just being trolled. Kind of doubt it though. .14 ohms. We're getting up there. I guess we could just inject a really low voltage. Just to kind of see where it might be. Still, well, I'd rather not unless I really have to. I don't want to cut any more than I mean, at this point, I guess it doesn't matter. And we're definitely going to need to run a wire around this IC here. This is very important. Which at my max of what I can take out here. Alright, I really want to get this short out of here. 10 ohms, that's better. Let's inject now. You leaving?
Yeah, I'm gonna head out soon.
Okay. iMac, how's that doing?
It's fine. I set it to sleep in 3 minutes, and it went to sleep and it came out. No lock screen. It's fine.
Paul Daniels is here. Yeah, this is a bad one.
Oh, Daniels!
Whoa!
How did that happen?
The iron was hot and it hit the flux syringe and melted in the side of it.
Oh yeah.
You're still sick. What happened? Did you have that flu thing as well? I'm still getting over that. Alright, we're gonna go down to 2 volts. We're gonna inject. Alright, we're pulling 5 amps at 2 volts. So now we're gonna switch over to thermal and we're gonna see exactly where this short remnants is. And if it's cold, then our short is somewhere else. Alright, there's our giant hole right there. You guys can all see that. Where is it? Alright. It's on that side. Got it. Kind of where I suspected it might be. Really don't want to cut any more right there though. That's the bad part, but we're gonna have to do it. I think we got it, guys. Let's see. How many ohms to ground on PP bus? 1.3 mega ohms, 1.3 million ohms to ground. Now the question is, what amperage do we take? Do we get our PP bus voltage? And can we enter DFU? My guess is going to be not yet because we have some rebuilding to do. This iron, this station is dying. Okay, here's a moment of truth. So I'm going to go back to front view and USB-C port. We're going to plug it in, see what we take. Before it was dead. It was gone. It was nothing on the USB ammeter. And hopefully now, okay, now we get it. 5 volts, 0.44. Interesting. So 5 volts, 0.44 means we have PP bus at some degree. You're missing other rails. So 5 volts, 0.44. Can you guys see this? Yeah. So 5 volts, 0.44 could mean USB-C communication. It means so many things. But alright, we have 8, 9 volts on PP bus. That tells me it's being pulled down. It's being pulled down somewhere. I don't know where. But the question is, can we enter DFU? So I am going to, actually, you know what, let's see if we have our T2 voltages. If we have our T2 voltages, that's a very good sign that we are good to go. We won't have NAND voltage yet. Sleep S2R. It's cycling, but it's there. Okay, so we're not going to enter DFU just yet, because that's cycling. So all of our rails are cycling for our PMIC. That could mean we have a broken trace somewhere. That could mean that something in this area is just, well, we know something in this area is bad, obviously. Or it could also mean that our PMIC power is cycling because of a broken trace for our PP3V3 VDD main. So let's see what PP3V3 VDD main is doing and then go from there. So PP3V3 VDD main can show up on any of these, or it's called PP3V3 G3H SOC PMU on this board. Cycling means the board is trying to get healthy, combination of aggressive weight loss removal and lots of cycling. I love that. That's perfect. So let's see what we have right here. Alright, so our 3v3 voltage cycles down. And I'm going to guess that's why we don't have steady voltages. So if we look at this, we have a trace that is cut right here. Let's just see where this goes. I think I know where it goes, but I want to make sure. And that would explain our cycling behavior right here. It's a miracle that's even cycling, that we have it there. Because basically that means that the PMU is communicating with the T2. And if it's communicating with the T2, I mean, we have a pretty good chance of data here. Despite all of this and despite what the morons in the comments section chose to say earlier about not wanting to send their expensive MacBook here because this is barbaric and this is this. P5V, P3V3, VRAF2. Got it. And that trace is for sure cut. That needs to go over to C7679. Okay. So this, what is this?
Alright.
Leaving?
Yeah, good luck to you.
Alright, drive safe.
iMac is playing video.
Alright.
Bye.
I don't see any damage to the NAND, so if I can get the T2 going, if I can get it to boot Bridge OS, then no, this is not a 1707. If this was a 1707, I probably wouldn't be doing this. This is a 2141, A2141, 16-inch MacBook Pro. Where's my jumper wire that I just had in my hands? Here it is, right from my face. bridge. Did you take apart the Hacko iron? No, I did not. I really don't plan to. Yeah, like 99 times out of 100, if this can get into DFU, the data is going to be just fine. So I really, really hope we're going to solder a wire across our forced DFU pins, and it is going to pop up on the screen and say DFU. And then we can grab our data. Just going to pin that like that for now. Okay. So without a VRF, that's very possible that it cycled like that, or was cycling like that. 5 volts, 0.44. The same. Let's see if our voltage is improved. No, it is still cycling. So at this point, I'm going to do more thermal imaging to see if something is getting hot with the cycle. Because sometimes cycling can mean other things. Well, usually on this board it'll mean a short somewhere. On any of the sleep or wake rails, anything like that. Just trying to. It's almost possible too that PP bus does not have enough juice to power that. Why is that diode getting hot? It's weird. Oops. Put this back in. I've gone too far in this board to give up now. Aha! Saw that. That could definitely cause a problem. Oh, what are you? Hello. Like I said, cycling. And this is... I see you. Okay. So this is probably why. There is something burned here. This poor board. There we go. That's what it was. So we gotta replace this guy, whatever this might be. Sorry I didn't show the thermal, guys, but yeah, this thing was getting hot and you could see why. Blue screen for a long time, says my girlfriend who's watching my stream. Does anyone else have a blue screen? Oh, just the mat on the desktop. Okay, that's what that was. Okay. Alright. So this thing, which I don't know what it is, has got to go. We're going to look it up. It definitely blew its lid though. Definitely see that. Okay, so this was. Oh, imagine that on PP3V3 G3H U8250. Okay, that would definitely cause cycling on it, undoubtedly, and that would also cause our awake rails to cycle because if PP3 hot cycles, the PMU's voltages are going to cycle. But at a minimum, now this has hope, so. I see that DFU icon pop up. We are probably good, and I will be here happy. Then we will pull the data tomorrow. But DFU means that we're talking successfully to our T2. It's booted Bridge OS to a degree, and I'm also going to remove all the backlight crap too. That's probably what's pulling down PP Bus at this point. So we don't need any of this stuff for backlight. This board is never going to power on again. We don't need any of this. So anything that could potentially cause a short, get rid of it. Backlight driver, backlight MOSFET. Whichever one comes off first. There we go. This. Good. Let it cool. Let's try again. Paul Daniel says, Tim is one of the few repair people who actually understands the design signals. Thank you, Paul. I appreciate that. It means a lot coming from you. Paul is much smarter than me. He's a great technician, and you should definitely subscribe to him if you're not. And buy his software. His software is simply the best. Look at that, 20 volts. Imagine that. We have 20 volts here. Bridge OS is booting. At this point, Bridge OS is booting. Our board's not turning on, but we're going to enter DFU, and this is we're going to get data from this. Let's see if I have my NAND voltages. If I have my NAND voltages, sometimes depending on the mode or the state that the T2's in, you will not get NAND voltages until you force it into DFU and force it to do something. But if I get my NAND voltages, which I don't yet, nah, okay. That's not a deal breaker. That just means that the NANDs aren't actively being kind of told to do anything. So we very likely will get those. So SOC force DFU. This top one right here, we're not gonna worry about the keyboard. There's probably severed keyboard lines, so I'm not going to do anything to force into DFU with the keyboard. I'm just going to run a wire across this right here. So, but we have 20 volts. That means our T2 is working to some degree. Don't care if it looks yucky. And I'm not going to exactly share how I'm able to get data in DFU mode, but it is in DFU. The chances are very high. Alright, here goes nothing, so let's see. Set my laptop on the floor. There's no reason why my laptop needs to be on the DFU station. And here is the Mac Mini, and we are going to open Apple Configurator 2. And so sometimes they're weird when they're out of the enclosure, but let's see what we get. Nothing here. What's that? That just recognized in DFU. Waiting for session. Look at that. So, you probably can't see that too well, but Apple controller state DFU. The ECID is identifying properly. The T2 is working. The T2 is talking to the NANds at this point to some degree. So, we're good to go. We are going to try and pull data from this tomorrow. But the chances of this are very, very, very high. We had to carve out a section of the board. We had to clear the shorts, but this is looking good. I think it's time for me to end the night, but this is looking very, very promising to get data off this board and save this person's data. But yeah, that's what it took. We had to carve out a good section of the board. We had to remove another shorted component. We had to deal with trolls that said that they would not send a MacBook to me because that's what I was doing. Well, guess what? This person's data just got saved because of what I was doing. And the other repair shop that you probably trust, not talking about Lewis's repair shop, but some other person, is not going to be able to do that. Sorry, but we're good to go. So, this should be good to go. I have confidence. If the here's my theory. If the T2 is able to work, we weren't around the NANds. So if we're not around the NANds, the chances of the NANds not being able to talk are very, very slim. So we got the board enough to provide voltages to the T2, to the NANds, and we should be good to go. I'm almost wondering now if it's in DFU like this, if I have my NAND voltages yet. Again, we won't often until the NANds are being told to. So, you know, let's see what we have. I don't want to try it. Yeah, let's just do this. No, I don't want to mess with it. Just to prove a point. If I were to hit revive device, it would fail because it's not going to turn on fully. But if we were to hit revive device, our 2B5 NAND and all those would pop up. Can you explain the jumpers you're using? We only used one jumper on this, and it was for 5V VREF, which we don't even need, but sure. So, I thought I did that on camera, unless my camera was off or something, I don't know. There is the only jumper that we used right there. That's it. So, but that's it for today. This was a win. We fixed a flex gate, we fixed an M2, all good to go. We told some trolls off. That's it. So, thank you guys for watching. I'll see you in the next